Hello everyone and welcome back to Arctic Retro. Just a short video here today. I want to go back to some poor job I did a while back. If you remember the video where I built this card for the XT PC. It's the XT CF Lite and I struggled a bit with soldering in this SMD CF card port here. I barely made it work in the end, but I did a poor job. I had to desolder it and resolder it, and I think I bridged some of the pins. However, it did work in the end, so the result was good. But I actually ordered 2 more cards with the CF card slot, and I want to try to practice a little bit with you. So I got a lot of feedback on that video with some very good tips on how to perform soldering like this, and that's something I always like to get feedback on my videos if I do something wrong or if I could have done something differently, so really appreciate that. So now I'm gonna try with these 2 cards. I'm gonna solder in this CF card port, but this time I'm gonna do it a little bit differently. One of the things that was mentioned in that video was that I should preheat the board, and as a coincidence I got this from PCB Way, if I can open it. It's a mini hot plate preheater and it's very mini, as you can see. So PCB Way, not only do they provide you with PCBs and 3D printing and sheet metal fabrication and stuff like that, they actually also have a shop where you can buy small gadgets like this. If I remember correctly, this one cost around $100 US. Very small, but it can be useful for small PCBs like this. I only need to heat the area around here. So I'm gonna try that out now, see if that helps. And this video is obviously sponsored by PCB Way, but this mini hot plate I didn't get from them. I actually won it in a competition at PCBWay.com, or it was actually a competition they held at Twitter or X, and I was their lucky winner by chance. This video is sponsored by PCB Way. If you need to have produced your own PCBs, then just visit PCB Way and you can get an instant quote for your own PCBs produced for as low as $5 US for 5 PCBs. They also do other stuff like advanced PCB. They do CNC machining and 3D printing, sheet metal fabrication and prototype PCB assembly, among other things. Also visit their shared project site where you can find a lot of already made PCB designs. So go ahead and visit PCBWay.com and check out their services. The mini hot plate came in this nice box. It doesn't come with a power supply. It uses USB-C PD, that's power delivery, and it can take quite some power. If I take a look in the manual, I'm not going to go through everything that this hot plate can do, but yeah, we'll see if it can help with simple things like this. Yes, and with USB PD you can actually pull 150 watts if you use 20 volts, and the temperature range is 100 to 350 degrees Celsius. No, I think I misread it. The max power if you use the DC input is 150 watts. Using USB power delivery it's 100 watts. Yeah, so it has a USB-C input and a regular jack, barrel jack input. No, currently I don't have such powerful power supplies, neither for the DC input or the USB, but I'm using phone charger here. That's for the iPhone, and it is, I think it's 40 watts or something. So you switch through the menus with these buttons, and obviously you can select different options here: heat, reflow, and the menu. And reflow is what we want. Select, you just press and hold, and there's various heating curves you can select and things like that. So now it's already heating up. The reason it's already on 50 degrees is because I just tested it just before I started filming. Now this is gonna take a while because I have such a weak power supply. It's only 40 or 45 watts, I think. Yeah, and it shows the curve which it is heating and how long it has been heating for. But I selected reflow. Maybe that is not the correct. I'm not really sure about the difference. I haven't studied this device really, just trying it out now for the first time. So let's select heat, and yeah, it's already at 81 degrees. Yeah, quite hot already. And it's currently set to 220 degrees, and that's maybe a little bit too hot. So you can just do like that. Let's set it to 180 then. And then I just put the PCB on top. Another comment I got was to use a flat chisel type solder iron tip like this. So that's what I'm gonna use. Also, an obvious tip was that just start with the SMD components first. I actually did it reverse. I started with all the other components and then tried to solder in the CF card slot afterwards. Yeah, it's still heating. It just reached 100 degrees after 2.5 minutes. Well, that's more like 3 minutes. It was hot from before. Thinking about it, I actually think 180 is a little bit too much. We're not gonna melt anything now. If I'm gonna remove a soldered component, then I would go higher, but I think 150 should be enough just to solder something. It's warm, alright. Can barely touch it. So the difficulty soldering such components is perhaps, as you can see, that the pins are very close and very narrow, so it's very easy to bridge the pins together. And there's a lot of techniques to do this manually. Obviously, if you have a stencil and can apply perfect amount of solder paste or something and use heat, then it's much easier. I don't have that. So I'm just trying here. I'm not an expert on this. I have never learned this anywhere. I just watched YouTube and tried to practice a little bit myself. Yeah, it's going very slowly now. As you can see, it's only using 9 volts. So yeah, I guess there's a limit then to how hot it can get. When this gets this hot, you might think that the phone charger gets hot, but in fact it's not. It's quite cool. It's much cooler than when I'm actually charging the phone. So what's the purpose of heating PCBs? Well, first of all, it is to help you melt solder if you have solder stencils and you have solder paste that you distribute and place component on top of. You heat the board from below and the solder melts and you get perfect soldering. However, in this case, I'm just heating up the board, and instead of using this, I could of course just have used my heat gun with hot air. Yeah, I think that's how high it want to go. I don't want to wait too much, so set it to 125 degrees Celsius then. See if it goes down quickly. But when doing manual soldering like this, this should help with the flow of the solder and hopefully get a better result. Yeah, it's quite hot right on the plate, but on the sides I can still hold it. So I think it's ready now. It went down to 123. I'm just applying a little bit of a liquid flux first. You can see it cooks away. This is actually for the most part isopropyl alcohol, I think, with some flux components in it. And another tip I got was to pre-solder the pads, and I didn't do that last time. Now, of course, this is a little bit difficult when the camera is in the middle here in the way. I try to move it a little bit, but yeah, I'm just gonna add a little bit of solder, a blob, to my solder iron tip. Shouldn't need to have much. Yes, I think we'll give it a try now. Just drag this solder over. Not sure if this is gonna show well up on the video, but yeah, it is what it is. Just drag it over like that, and that pre-tins all the pads. That looks alright. Then I'm gonna add some regular flux. Flux is supposedly your friend in these cases. Of course it's gonna melt. That looks to be a lot of flux, but yeah, I think it's okay. And luckily there are some guiding holes for this port. So it will align itself quite perfectly. And then I'm gonna solder in these these supports on the side. Just a little bit so that I can adjust it a little bit if I need to. Just push it down so it's really flush. Oops, it got too hot. Yeah, at least now it should be aligned. All the pins look to be perfectly aligned to the pads. It's soldered on the sides. So one mistake I think I did last time was that I had the pointy solder tip, very thin one, and I dragged it on top of the pins, and then it made a lot of bridges, very difficult to remove. Now I have this flat iron, and I'm gonna just drag it along the side. Okay, so I have solder on the tip, just a tiny amount. Try to drag along. There should be a little bit of solder already. Okay, I already can see I did a mistake. I didn't pay attention enough. You can see it became a lot of bridges over here. So now I just try to drag that away. Seems to work. So I just add a little bit flux there where the bridges are, and use a little bit of solder braid or wick just to remove that. Yeah, I think that went well. Yeah, I don't know. I think that looks okay. If you don't have a microscope, it's kind of hard to actually see if everything is okay. Thing is that there might be solder sneaking in under the contact behind the pins. Let's see if all the pins are solid. Just push every pin sideways a little bit. I mean, if they're not soldered, then they should bend. Yeah, but they all looks to be soldered. Maybe this was a success then. Now I'll do the other one. Same drill there. So this one actually turned itself off after a while. So I need to reheat it again, but it's 90 degrees already. Same deal. Add a little bit of liquid flux first. Add a little bit of solder. Yeah, it's already 100 degrees. Drag it over. Oh, maybe that's a little bit too much. I don't want a lot of solder on these. Place the board, solder it in. Check alignment on the pins, looks good. Push it down. Then add some flux. Like Alex says in the Northridge fix, you never can have too much flux, I think. Clean the tip. Add a little solder. Now I try to drag it only on the PCB itself and not on top of the pins. Still I got a couple of bridges there. Yeah, but I think that went okay. There's very little solder, but that's how it should be. You can't have a lot of solder with those small pins. Try to remove the solder bridges there. Yeah, that's sucked away. I think there's a little bit more. Yeah, now it looks good. Yeah, that looks perfect. Yes, I think that's even better result than the first. All the pins are solid. So I'll go through everything and check. But I was thinking maybe it's a good idea now to turn up the heat if I can. Yeah, I need to figure out what reflow actually is used for. But let's crank it up now to 300 just to see if it can reach any high temperature, and then I just heat up the PCB. Maybe the solder will melt a little bit and becomes better. While we wait for that, I actually found the one pin, the leftmost here was loose. So I just touched it with my iron, and now it's solid. So I think this is good to go. Just clean it up with some IPA, remove the flux. Now I'm gonna check that there's no pins that are shorted. But be aware that a lot of these pins goes to the same ground and 5-volt lines, so some of them are in fact connected together. No, 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 no. Yeah, this looks good. For example, the pins here on this area is all ground pins. So all those 4 or 5 pins there are ground. So that makes it a little bit difficult to check all the pins, but you just check the layout of the PCB if you want to know exactly which pins goes where and how they are connected together. No, I don't think this is gonna reach much higher temperature than this 8 minutes, and it hovers around 140. For me to use this properly, I need a better power supply. Alright, I have checked both PCBs now, and all the pins are solid. I cannot detect any connections that shouldn't be there. So hopefully this works. So that was it. Now I need to populate the rest of the components. Unfortunately, I don't have those components, so I cannot test for real if this job was a success or not, but everything looks promising. If not, then I think it's just a matter of trying to add some flux, heating up the pins a little bit, dragging along the pins, and see if you can resolve any bridges. Now, obviously you can do this without such a hot plate. Just try to use it to help me to get a better result. If it actually was any help or any good at all, I'm not sure, but still nice to have. Alright everyone, that was it for this video, just a short one. Hope you enjoyed it. I for sure learned something I got some practice, and it seems like I'm getting better at these kind of solder jobs. So yeah, that's how it is. By practice you learn and get better at stuff. Thanks a lot for watching, and a special thanks to my patrons and my members at YouTube. See you!